In this lab, we will analyze the data for urban-rural classification based in Scotland. So we import pandas as PD, and then we read the CSV file, pd.read_CSV, and then this is the name of the CSV file, and then when we print the first few lines of this data frame, we get this. So we have 92 different variables. Then we will import Seaborn as SNS and import matplotlib.pyplot as PLT. We are going to plot histogram, but we are going to get warnings. So to avoid that from printing, we will import warnings, and then we will pass this command warnings dot simple filter bracket ignore. This will ignore all warnings. Then we plot the histogram of income rate. So sns.hist plot bracket data equal Scott, comma x equal income underscore rate, comma state equal count, comma bins equal 10, and comma color equal blue. Add a title to the plot. So x equal plt.gca, this is the current access object, and we set title x.set underscore title as histogram of income rate versus number of people, and then plt show. So this is the histogram of income rate versus number of people. So when we provide descriptive statistics, so the column income rate dot describe open and close bracket, as the income rate increases, the number of people employed decreases. So you can see as the income rate increases, the number of people decreases. The income rate has mean of 13.79 from the descriptive statistics. The maximum income rate is 65 and the minimum income rate is 0. The median income rate is 11. So the median income rate is the 50% quartile, and which is 11. From the graph, most of the people employed are having income rate below the median of 11. So 11 is over here, and we can see most of the people are having income below 11. Then we plot the histogram of employee underscore rate, sns.histplot of data equals Scott, comma x equal employee underscore rate, comma state equal count, comma bins equal 10, comma color equal yellow. So, and then we want to add a title. So x equal plt.gca, open and close bracket, then x dot set underscore title of histogram of employment rate versus number of people, plt.show, and that prints the histogram of employment rate versus number of people. So, and now we look at the descriptive statistics of employee rate. So dot describe open and close bracket will give the descriptive statistics. The number of people decreases as the employment rate increases. So that's from this histogram. The maximum employment rate is 73. The minimum employment rate is 0. Yes. Yes. And the mean employment rate is 13.33. From the graph, more people are employed with the employment rate less than the median employment rate of 11. So 11 is over here, and more people are employed with employment rate less than 11. Then we plot the histogram of private rent. So sns.histplot of data equals Scott, comma x equal private underscore rent, comma stat equal count, comma bins equal 10, comma color equal purple. Then we add a title to the plot using the x object after creating the plot. X equal plt.gca open and close bracket, x dot set underscore title of title so is histogram of private rent versus number of people. Then plt dot show open and close bracket, and this is how the histogram looks like. Then we provide descriptive statistics of private rent. So Scott square bracket private rent dot describe open and close bracket. As the private rent increases, the number of people decreases. So that's from the graph here. The median private rent is 62. That's the 50% quartile. And the maximum is 1372. The mean private rent is 95.21, and from the graph the number of people with private rent for up to 100 is much higher compared to private rent of above values. Then we get the shape of the data frame, that is rows and columns. So print bracket scott.shape, and that will give the number of observations has 6,500 and the number of variables has 92. Then we get the column names by printing bracket scott.columns, and it prints all the column names over here. Then we get a concise summary of the data frame, and that is by doing scott.info open and close bracket. So there are 6,500 observations and there are 92 columns, and the data type of each of those columns is given here. And yeah, so 21 variables are of float 64 and 59 are of int 64 type and 12 are of object type, and the memory usage is 4.6 about 4.6 megabytes. How are the variables coded? So 12 variables are coded as of object type, 21 variables are coded as of float 64 type, and 59 variables are coded as of integer type. In the data frame, variables now call M25 to 64, now call F25 to 64, and now call total 25 to 64 give the number of men, women, and total population aged 25 to 64 with no educational qualifications. Then we calculate the percent of men in that age range with no qualification. Use the variables all M2564 as denominator. So we let Scott, this is the name of the new column, men underscore percent equal. So what we're doing over here, now call M2564, we divide those values by all M2564, and then we multiply by 100 and we round that to 2 decimal places. And when we print that, it prints like this. Then we look at the distribution of men with no qualification. So sns.histplot of bracket data equal Scott x equal main underscore percent. That's the new column of this percentage values. Stat equal count, bins equal 10. Then we add a title to the plot using the x object, x equal plt.gca open and close bracket, x dot set underscore title of histogram of percent of men with no qualification. And when we display the plot, we get histogram percent of men with no qualification and the descriptive statistics of that men underscore percent dot describe open and close bracket. Number of men with no qualification is distributed from 0 to 69.7 with the mean of 22.41. The percent of men with no qualification increases for up to the percent of men with no qualification increases for up to the median of median, which is 50% quartile, 21.19, and then decreases. So let's look at the graph. So it increases up to the median and then it decreases. Calculate the percent of women in that age range with no qualification. Use the variables all F25 to 64 as denominator. So we create a new column women underscore percent and we do no qualification for female for age range 25 to 64 divided by all female with the age range 25 to 64 and then we multiply by 100 and then we round that to 2 decimal places. And when we print that column values, we get this. Then we look at the distribution of women with no qualification. So SNS dot hist plot of data equals Scott, x equal women underscore percent, stat equal count, bins equal 10, color equals sky blue. And when we add a title, so x equal plt dot gca open and close bracket and x dot set underscore title, and then we put the name of the title that we want. Histogram of percent of women with no qualification, and we show that display the plot. So we get this. And we provide descriptive statistics of percent of women with no qualification. So dot describe will print that number of women with no qualification is distributed from 0.5 to 63.92 with the mean of 20.5. The percent of women with no qualification increases for up to the median of 18.69. You can see increases and then it decreases and then decreases. Then we calculate the percent of total population in that range with no qualifications. Use the variable all 25 to 64 as denominator. So we create a new column and we name it as total underscore percent, and that equals to no qualification column for the total age range from 25 to 64, and we divide that by all total 25 to 64. And we multiply that by 100 and we round it to 2 decimal place. And when we print the column, we get this. And we look at the distribution of total men and women with no qualification. SNS dot hist plot data equals Scott, comma x equal total underscore percent, comma stat equal count, comma bins equal 10, comma color equal red. And we add a title to the plot using the x object after creating the plot, x equal plt dot gca open and close bracket. Then we add the title x dot set underscore title, and we put the name of the title in the inside the bracket. Histogram of percent of total men and women with no qualification, and we display the plot. And we find the descriptive statistics of this new column of total men and women with no qualification, and that is possible by doing dot describe open and close bracket. So total percent of men and women with no qualification is distributed from 0.68 with to 65.65 with mean 21.44. Total percent of men and women increases up to the median of 20 and then decreases. How many data zones? Special Administrative Unit in Scotland have over 20% of people aged 25 to 64 with no qualifications. So we create a column with ones if total percent is greater than 20, else 0. So let the new column, we call this over 20 underscore percent equal, and let the values be 0. Then for I in range 0 to length of Scott. So length of Scott is the total number of observations. Then we put the colon if the total underscore percent of each of those rows is greater than 20, then over 20% for that row we put 1, else over 20% for that row we put to 0. Then we print the total percent and over 20% columns. So this is how we do that. So the column name total percent, if the total percent is greater than, so we want the data frame and we want to print the columns which are having the total percent greater than 20. And then we want to display the total percent of that, and we over 20%. So we can see that all these over 20% values, and yeah, so total percent is over 20, and over 20% column will have ones. Calculate the number of data zones with over 20%. So this is how we do that. So the name of the column over 20%, then we do dot value underscore counts, open and close bracket. So when we print that, we get 3,242 data zones, that is Special Administrative Unit in Scotland, have over 20% of people aged 25 to 64 with no qualifications. Then we summarize the variable UR8 fold. So first we provide the descriptive statistics of that column UR8 fold. So Scott square bracket UR8 fold dot describe open and close bracket, and it prints this. UR8 fold variable has mean 2.629 and median 2. The values of this variable are distributed from 1 to 8, with the first quartile 1 and the third quartile 3. What type is this variable? So when we do dot info, open and close bracket, we get the type of variable, and that is int64. Variable is of integer type. But then the values are 1, 2, 3, 4, 5, 6, 7, 8. So it is of category type. So we need to change the variable to category type. Anyways, let's continue. So create an ordered factor variable of the 8-fold urban rural classification. Try to a short but descriptive variable level. I don't know. So to learn more about UR8, we will just remove this sentence, which is not quite correct. To learn more about UR8 fold 2016 urban rural 1 classification, the uh, the the web page address is this one. Then we create sample data. So what we want to do is we want to replace those numbers in the UR8 fold column to these values here, the real values. So one will be large urban areas and so on, and two will be other urban areas and so on, and three will be accessible small towns, and four will be remote small towns, and five will be very remote small towns. Six will be accessible rural areas. Seven will be remote rural areas, and eight it represents very remote rural areas. Now the three dots on the right represent that we are not finished with the true value there. But anyways, let's use these three dots. Otherwise, in the data frame itself, we need more space. So let's put this in curly braces because we going to create a dictionary. So here, filter out extra levels. So what we're doing over here, we look at the values, the unique values of this column, UR8 fold. So it's 316278445, and if we order that, that will be 1, 2, 3, 4, 5, 6, 7, 8. Then we create dictionary of categories. So this category that we created over here, we will convert this to dictionary values. So DICT and then open bracket, categories, close bracket, and when we print that, it prints like this. Map levels to real values using the dictionary. So it's square bracket, categories dot get level for level in filtered underscore levels. So filtered underscore levels is the unique values of this column UR8 fold. So for each of those levels in filtered underscore levels, we will put that to categories dot get level, and you can see that. First one was 3. So 3 is replaced by accessible small towns, and the next one is 1, and 1 is replaced by large urban areas, and next one is 6, and 6 is accessible rural areas, and next one is 2, and 2 is other urban areas, and next one is 7, and 7 is remote rural areas, and next one is 8, and 8 is very remote rural areas, and next one is 4, remote small towns, and next one is 5, and that is very remote small towns. Then we create a new column UR underscore 8 fold underscore kit with categorical data and labels, and we put a square bracket, and we use mapping underscore dictionary, the one we have used over here, dot get level um, for level in Scott UR8 fold. So what we are doing is that the column UR eightfold, which contains the numbers 1, 2, 3, 4, 5, 6, 7, 8, we are replacing with that with the dictionary values. And we are putting that into new column named UR underscore eightfold underscore cat. And when we print UR eightfold and UR underscore eightfold underscore cat, and we print the first few lines, so that's dot head open and close bracket, we see this. Then let's look at the unique values of this new column that is printed, and we can see that 1, 2, 3, 4, 5, 6, 7, 8. UR eightfold variable is unique, has vector type with the 8 levels as listed above. Should be underscore cat. Then we create a 3-category variable from the eightfold urban rural classification that groups data zones into accessible areas, including urban areas, remote areas, and very remote areas. Now, create sample data with missing values and an extra level. Okay, so we let categories equal curly braces. Now, large urban areas will be known as urban areas, so urban, and then other urban areas will be known as urban. Accessible small towns will put that into urban category. Accessible rural areas, we will put that into urban category. Remote rural areas, we will put that into remote. And remote small towns, we will put that into remote. Very remote rural areas, we will put that into very remote. Very remote small towns, we will put that into very remote. And we print that. That is how. And we create a dictionary of these categories, and we let it be mapping underscore dict. So now it's converted to dictionary. And we convert it by doing DICT open bracket categories and we close bracket. Create a new column UR underscore eightfold 3 with categorical data and labels. So square bracket. So mapping underscore dictionary, which is this one, and dot get level for level in UR underscore eightfold underscore cat. So yeah, so for this column that we had created, we replace that with this mapping dictionary, urban, remote, very remote, and we put that in the new column, and we will call that column UR underscore eightfold 3. And let's print only the two columns UR underscore eightfold underscore cat and UR underscore eightfold 3, and let's print only the first few lines, and we see that accessible small towns is 7, large urban areas is 7, accessible small towns is 7. Calculate the size of each category, and UR underscore eightfold 3 dot value underscore counts open and close bracket. So we get there are 5,808 urban data zones, 380 remote data zones, and 312 very remote data zones.